Title: Local suppression of blue-weighted irradiance in a recessed porch cavity under magenta uplighting with co-located induction heating, and tobacco aerosol emissions. A working theory with quantitative framework. Author: Mustafa, Site Investigator. Analysis Support. GPT-5 Pro. Abstract: a residential porch exhibits reduced nocturnal insect presence when illuminated by consumer RGB LED operated in magenta mode, and partially shrouded under a balcony. The site investigator also operates handheld induction heating devices for tobacco consumption, for example, IQOS Illuma/I Prime, in the same space. Therefore thermal plumes and aerosol emissions co-occur with lighting. This report provides a geometry-first radiometric model for blue-weighted photon flux, augments it with short-wavelength absorption by the shroud, adds line-of-sight/solid angle restrictions imposed by the porch cavity, and explicitly incorporates magnetic induction field magnitudes from a small coil. Roman 2, buoyant plume transport from warm exhalations, and Roman 3, aerosol optical extinction. A simple local selection/learning model for fauna composition is included. Order of magnitude calculations indicate that the magnetic near field from the handheld induction coil is several orders of magnitude below geomagnetic background beyond a few centimeters, and is not a controlling variable. B. The combined geometry and towel transmittance reduce escaping blue flux by 10 to 10.3, and C. Fresh aerosol near the aperture further attenuates blue by Beer-Lambert extinction, and reduces green channel leaf contrast, compounding the deterrent effect. The framework yields falsifiable predictions. Keywords: artificial light at night, action spectrum, cryptochrome, magenta lighting, cavity optics, aerosol extinction, induction heating, buoyant plumes, selection dynamics. 1. Introduction: spectral content, geometry, and ambient competition jointly determine biological responses to artificial light at night. Allen. In many nocturnal insects, short wavelengths, near UV/blue, drive phototaxis and circadian entrainment, while deep red/amber are weakly effective. The present site is a recessed porch with hedge boundaries. Consumer RGB LED pole lights are operated as uplights and are partially shrouded with a towel. The investigator frequently uses handheld induction heating devices for heated tobacco sticks on the porch. Reduced insect presence within the porch volume is reported under these conditions. The objective is to model the physical field that reaches the insects, and to identify which terms control the outcome. 2. Symbols and definitions: e.e. lambda. Spectral irradiance, WM2NM1, phi, lambda. Spectral photon flux density, photons M2S1NM1, lambda. Action spectrum, unitless, 0-1, Bay. Biologically effective irradiance, photons M2S1, I, lambda theta. Spectral intensity in direction theta, WSR1NM1, A. Aperture radius, M, H. LED depth below aperture, M, theta. Escape cone half angle, rad, F, theta. Escape fraction, unitless, TB, TG. Towel transmittance in blue and green bands, unitless, R. Range to evaluation point, M, G, theta. Directional factor toward open air, 0-1, H. Heaviness ratio vs ambient, unitless, M. Magnetic dipole moment of induction coil, M2, B, R. Magnetic field amplitude on coil axis at range R, T, omega. Angular frequency of induction drive, rad S1, kxb. Aerosol extinction coefficient in blue band, M1, tau b. Blue band optical depth equals kxbl, unitless, w, z. Plume centerline vertical velocity at height z, ms1. Qualitative usage. 3. Radiometric fundamentals 3.1 photon conversion phi, lambda, equals E, lambda, lambda slash, HC. 1. 3.2 biological weighting BDI equals integral A, lambda, phi, lambda, d lambda. 2. In the two-line LED approximation, blue line at lambda be approximately 450 nm, red line at lambda are approximately 630 nm. The blue weighted BDI is dominated by the blue term, because lambda are approximately 0 for deep red in most nocturnal insects. 4. Aperture and escape cone geometry. The hooded uplight is modeled as a cavity with circular aperture. The escape half angle is theta equals arctan A/h. 3. Assuming near Lambertian emission, the fraction of radiant power escaping to the far field is f theta equals 1 minus cos theta / 2. 4. 5. Short wavelength transmittance of the towel. Short wavelength content is reduced by absorption and multiple scattering. A Beer-Lambert effective form is adopted. TB equals x minus alpha BL SB. 5. With alpha B an effective blue band absorption coefficient, L an optical path length through fabric, and SB 0.1 incorporating pore/scatter losses. A similar form can be defined for the green band, Tg. 6. Blue band irradiance at range with cavity and fabric. Let the lamp's raw blue radiant power be PBW. Escaping blue power is PB out equals PBF theta TB. 6a. Irradiance at range are in a direction characterized by G theta is EB local R theta equals PB out G theta / 4 pi R2. 6b. 7. Aerosol optical extinction from heated tobacco use. Fresh aerosol, submicron, adds wavelength dependent extinction near the aperture and within the porch. For path length LR, lamp to aperture, and / or insect, blue band attenuation is EB local air equals EB local x minus tau b, with tau b equals kxblr. 7. Because extinction typically increases toward shorter wavelengths for fresh smoke, kxb greater or equal to kxg, which further suppresses the biologically active blue compared with red. 8. Magnetic induction fields from handheld heater. Relevance: the induction heater coil is approximated as an oscillating magnetic dipole with moment m. The on-axis magnetic field amplitude at range r, quasi-static near field, is b, r, approximately, μ0 / 2 pi, m / r3. 8. For a compact coil, illustrative. N approximately 10. I approximately 2 a peak, radius approximately 1 cm right arrow m approximately 2 times 10 3 m2, b 0.10 m, approximately 0.4 micro t, and b 0.05 m, approximately 3.2 micro t, both far below the geomagnetic field, 2565 micro t. The R3 decay and brief duty cycle imply negligible magnetization, or depolarization / repolarization, of environmental materials beyond a few centimeters. Consequently, magnetic polarization effects are not retained as a control parameter in the biological model for this site. 9. Buoyant plumes from warm exhalations. Qualitative, heated tobacco use produces warm exhalations and buoyant plumes. Classical plume scaling, Morton-Taylor-Turner, predicts centerline velocity W, Z, proportional to B0, 1/3, Z minus 1/3, for buoyancy flux B0. In practice, this yields upward transport at cms1 near the mouth with rapid lateral dilution. The effect is to I. Lift aerosol toward the balcony cavity, increasing local tau B, and Roman 2. Advect scent molecules away from the porch interior. The plume modifies concentration fields, but does not change the radiometric geometry. 10. Green channel contrast for host finding for herbivores that use a green channel. The Michelson contrast is Cg equals Ig leaf minus IgBg / Ig leaf plus IgBg. 9. Magenta illumination plus towel absorption reduces incident green, thereby reducing Ig leaf and Cg within the porch volume, impairing host detection locally. 11. Local selection / learning model. 2 behavioral classes are considered: approachers, A, and avoiders, V. If nightly survival near the porch satisfies S equals X minus alpha BI local, and SV equals 1, the odds ratio Rn equals Pn / 1 minus Pn evolves as Rn plus 1 equals RNS Rn equals R0X minus alpha BI local N. 10. Thus Pn equals R0X minus alpha BI local N / 1 plus R0X minus alpha BI local N. 11. Composition shifts are rapid when alpha BI local is non-zero, giving the appearance of resistance without invoking genetic change. 12. Combined heaviness ratio with aerosol term with all terms assembled. A blue weighted heaviness ratio versus ambient is H equals a B, lambda B, PBF, theta, TBE minus, tau B, G, theta, / 4 pi R2, lambda B / HC, / BDI ambient. 12. For two-line LED, and a B, lambda R, approximately 0, red does not contribute to the numerator. When H1, the porch is locally biologically dim relative to ambient. When H1, deterrence is expected. 13. Order of magnitude example, site-relevant numbers, assume A equals 0.05 m, H equals 0.08 m theta approximately 32.0 degrees, and F, theta, approximately 0.076 ec. 4. Assume TB approximately 0.15, fabric reduces blue, and KXB approximately 0.5 m1 in the first meter after exhalation, illustrative indoor value. So tau B approximately 0.5 for L air equals 1 m. Then the effective escape factor in blue is FEFF equals FTBE minus tau B approximately 0.076 0.15 0.607 approximately 0.0069. For PB equals 1 W, R equals 5 m, and G, theta, approximately 1 toward the opening, ec. 6b, 7, give EB local air approximately 2.2 times 10 minus 5 Wm minus 2. If ambient blue in the open yard is 2 times 10 minus 2 Wm minus 2, then H approximately 1.1 times 10 minus 3, 3 orders of magnitude dimmer, consistent with reduced attraction, regardless of perceived magenta color. 14. Predictions, falsifiable, 14.1 geometry. Increasing aperture, or decreasing depth H raises F, theta, and H removing the towel raises G toward open air, and increases H 14.2 spectrum. Reducing the blue drive channel decreases H nearly linearly under the two-line approximation. Adding an amber filter lowers H further while preserving a magenta appearance to human observers. 14.3 Aerosol. Immediately after exhalation near the aperture, higher tau B, H decreases. Several minutes later, dilution, tau B right arrow 0, H increases toward the towel-only baseline. 14.4 Magnetic induction. Varying the heater duty cycle, or position beyond a few centimeters will not measurably change H, or insect counts. B. R. Ec. 8. Is subgeomagnetic at biologically relevant distances. 14.5 Composition. Predator counts, spiders, geckos, bats, co-locate initially, and then decline as PN of approaches falls, x. 10-11. 15. Measurement methods, practical, 15.1 Spectral estimation. Smartphone plus DVD grating. Record EE, lambda, with/without towel. Relative spectra suffice. 15.2 Angular intensity. Fixed exposure photos across angles estimate G, theta. 15.3 Aerosol extinction. Place a white card behind a standard path length, and record blue channel intensity decay immediately after an exhalation vs 5 minutes later. Infer tau B from ln, I0/I. 15.4 Ambient reference. Perform the same spectral capture in the open yard. Compute H via rec. 12. 15.5 Counts. Sticky cards in porch vs yard. Nightly counts correlated with H, and time since last exhalation. 16. Limitations. The towel is modeled with effective TB and TG, though they are angle and wavelength dependent. Aerosol coefficients vary with particle size distribution and humidity. The induction coil is treated as a magnetic dipole. Near-field complexities are reduced to R3 scaling. PWM flicker is not modeled. These limitations do not change the controlling result at the numerator of VEC. 12 is dominated by escaping blue photons. 17. Conclusions. When magenta uplighting is operated under a balcony and shrouded with fabric, the combination of escape cone geometry and short wavelength transmittance strongly suppresses escaping blue-weighted photon flux. Heated tobacco use co-located with the lamp introduces additional blue suppression via aerosol extinction, and generates buoyant plumes that confine aerosol within the cavity. Magnetic induction fields from the device are negligible beyond a few centimeters, and do not control biological outcomes. The extended heaviness ratio H, Ec. 12, formalizes the conditions for local suppression. The framework predicts the observed deterrence, and yields testable signatures without invoking non-physical mechanisms. Appendix A. Derivation of the escape fraction F, theta, power transmitted through a circular aperture accepting polar angles 0 less or equal to letter 3d1 less or equal to theta is proportional to integral 0, 2 pi integral 0 theta cos letter 3d1 sin letter 3d1 d letter 3d1 d phi equals pi sin 2 theta normalized by hemispheric power pi. The escape fraction is F equals 1 minus cos theta slash 2. Appendix B. Magnetic dipole field. The magnetic field of a dipole M on axis is B, R, equals mu 0 slash 2 pi, M slash R3. For M in the 10-3-10 to a M2 range, and R greater or equal to 0.05 M, B is in the micro T regime, below geomagnetic background, and rapidly smaller with R3 decay. Time variation at omega does not change this quasi-static scaling in the near field for environmental distances considered here. Appendix C. BDI under 2-line approximation with aerosol for line spectra at lambda b and lambda r with photon fluxes phi b out and phi r out. BDI local approximately a lambda b phi b out e minus tau b plus a lambda r phi r out e minus tau r. With a lambda r approximately 0, the blue term dominates the numerator of H, Ec. 12. Appendix D selection dynamics timescale from EC 11. The folding time in nights is tau cell equals 1 slash alpha BDI local. Small non-zero BDI local yields rapid composition change. If BDI local right arrow 0, the composition freezes.